Okay. All right, let's go. Focus. All right, so like we said with the overview, okay, we're going to kind of divide the quizzes up into chunks. So like this half here is you don't have to write this, by the way. It's basically your first quiz. Okay. And then this chunk here is quiz 2. Now, Miss Alex really looked this stuff over. This quiz here might not happen because it's kind of really close to the test. We may just give you one quiz, do a review, and then take the unit test. Like I said, this is kind of a short unit, okay? And we're going to simplify it up a little bit with some more traditional math, okay? So today we're going to get into finding square roots. We're going to do that over a few days, and then the next thing we'll get into is the Pythagorean Theorem, kind of the whole basis of what we do here. So to do all this stuff, we get into squares and cube roots, which you've had a little bit of experience last year with square roots a little bit in the geometry stuff, because if you did right triangles last year, you got introduced to squares a little bit. Okay. We get into rational and irrational numbers later on. That's like, you've kind of done that before, like the real number system. Probably had a little bit of experience with that in 6th grade. We're going to refresh that. So that's kind of how this is going to look. So here's what we're going to start with. A couple pages in, where it says 91 square roots, we have a couple explorations here. Okay. So we're going to see your knowledge right now on squares and square roots. So let me, you got exploration 1 here, which has a square. Okay, and you notice here they give you areas of these 6 squares. Who remembers the formula for area of a square? Logan? Yeah, it's length times the width, right? Now, we did some experience with that with rectangles early on, right, with the inverse variation. But now, what makes a square a little bit different than a rectangle? What's very unique to a square that a rectangle doesn't have, Amanda? Yeah, all the sides are the same, right? That's why you see a S and an S here. Because if this number is like 3, so is that number, right? Because it's 3 all the way around the square, because all sides are the same. In a rectangle, 2 sides are the same, right? The opposite sides, right? All right. So you're going to do this part first with the people at your table and come up with these side lengths for these 6 areas. All right. Then down below, you got basically it says solving an equation. Well, some number squared. Because remember, if it's an equation, it has to have what? What makes an equation an equation? Anyone know? The equal sign. Because isn't the word equals kind of in equations? Right. So you're going to solve for x. What number squared, meaning what number times itself, gives you 0, 1, 2, 4, and so on. Okay? So we're going to give you about 15 minutes to work on these 2 little explorations, and then we're going to come together and see how you did. Okay? So with the people at your table, guys, talk it out a little bit, work it out, use the calculators if you need to. Okay? By the way, the calculator, if you need the square or square root button, the square button is right here, which says x squared. So let's say if you had to take 5 squares, you hit 5, hit the x squared button, and see how it does that, and it will tell you what that number is. If you need to figure out what the square root of something is, notice it's the little blue button above x squared, right? Well, to get to that blue button, you have to hit the second function button, x squared, and that gives you the square root button. Okay? All right, so I'm going to pause our little video right now where you guys take about 10 to 15 minutes and work on our 2 explorations. All right, go. So if we had a square with an area of 81 square yards, remember when we talk about area, that's a square measurement, right? Because we're talking about all this. Well, we're doing side length, right? Which is a single unit measurement, right? So what would a side length have to be for the area to be 81? 9, right. How'd you figure it out?
9 times 9 is...
Okay, so you know that 9 times 9 is 81. All right, so the side length here is 9 yards. Okay. But what about if the area was 324? Jacob? 18. So again, our side length would be 18 centimeters. Very good. What about at 361? Gabrielle. 19, right? One higher. 19 times 19 is 361. That would be miles. 225, Peter. 15. Did anyone find it differently than going, you knew what one number times a number was? Oh. Just out of curiosity? Yeah, they took the square root of a number, right? Which we'll talk about in a minute. So I said you could do 15 times 15 is 225. Or they knew that the square root of 225 you put in the calculator was 15. So those are two ways that you could find that. So that's 15 miles. What about 2.89? Jackson. 1.7. That's inches. And then what about 4/9? 4/9. Logan. It is 2/3. 2/3 of a foot. Because if you take 2/3 and multiply it by 2/3, when you multiply fractions, you multiply across, and you multiply both numerator and denominator. Where like when you added fractions, you only add the numerators, right? Denominators stay the same. But multiplying, it changes. So this just becomes 2 times 2 is 4. 3 times 3 is 9. Okay? All right, good. Now, what about down here? What number times itself gives you 0? 0, right? That was kind of an easier one, right? There's no other number. What about when you have 1? Logan. There's more than one answer here. Think about this for a minute. How do the sign rules for multiplying integers help you find the solution? Think about what an integer is. 1 is an answer. There's also another one. Think. Huh? That's 0.5. That's only if you add it. 0.5 times 0.5 is 0.25. Change. Nope. Either? Nope. That's not a number. What is a negative times a negative? So -1 times -1 is 1. So not only is it 1, it's its inverse. It's opposite. So what would 4 be? What number squared gives you 4? 2 and? -2. Yes, 2 answers. 9 would be 3 and -3. 16 would be 4 and -4. And then 25, 5 and -5. You're thinking adding, multiplying. When you got a number squared, okay? When you got a number squared, it's saying some number times itself gives you that number. It's not adding. So if you take 0.5 and multiply it by 0.5, you get 0.25. You don't get 1. Okay? All right. So we're getting into the first example here. 9-1 lesson. So 2 more pages in. So we all know the symbol for a square root. Right? It's like a little house there. Okay? So this first sentence says, so a square root of a number p is a solution of the equation x squared equals p. This is kind of what you just did down below there, right? You got x squared equals 4, and we found out to be 2 and -2, right? Okay? So it says every positive number, so whether you're looking for 4, 9, has a positive and negative square root. Okay? Because again, a negative times a negative gives you a positive. So not only does a positive number work, the negative number works as well. Okay? And perfect squares deal with integers as its square root. So There's usually about 15 perfect squares you should memorize. Okay? I'm going to write them right here. 1 squared, 2 squared, 3 squared, all the way to 15. We all know what 1 squared is, right? 2 squared is what? 4. 3 squared? 4 squared? 5 squared? 6 squared? 7 squared? 8 squared? 9 squared? Yep. 10 squared? 11? 121. Good. 12? 144. Then it goes 13 is 169, 14 is 196, and 15 is 225. Okay? Those are about the squares you should kind of know without having to use a calculator. Okay? So if it asked us, find 2 square roots of 49. Well, remember, you got to just understand that the root can also be positive as well as negative. Okay? Because again, when you multiply the numbers by themselves, you can always find the positive and the negative because they're squaring. Now, if we're cubing it 3 times, negatives usually don't work then because, right, a negative times a negative times a negative goes back to a negative. We'll get into that later. We'll have that conversation. So right now, I want you to take a couple minutes, and I want you to find me the 2 square roots of these numbers, 36, 100, and 121. Give you guys a couple minutes to go over that. The people at your group, and then we'll see how you did. All right, 2 roots, so you're talking positive and negative. So for 36, do you?
6 and negative.
Yep, this is 6 and negative 6. Sometimes you see them right this way. Positive, negative, 6. Okay. 100. 100. Yeah. 10 and negative 10. And 121. And above.
11 and negative.
Yep, 11 and negative 11. Now remember, sometimes we have, there's multiple words that you can use to describe square root. Sometimes it's called the radical sign. And we refer to the number underneath the radical. So like if you have the square root of 81, 81 itself that's under the radical, we call the radicand. That's what they came up with. All right. So when you're given 3 examples here of a square root, if you're just given the square root of some number, when you find that root, that's going to represent the positive square root of something. So for example, I'll use the same number 3 ways. So the square root of 81 is 9, because that's saying that's the positive root. If I put a minus sign out in front, you're taking the negative root of that number. So the negative square root of 81 would be negative 9. Now, if you see that plus minus out in front of the root, now they're asking for both square roots, which would be plus or minus 9. Okay? So in our next example, that's what we're going to get into. These type of problems. Okay? So you can see when they have the square root of 25, they're asking for the positive square root. So it's 5. Okay? Once the minus sign gets out in front, if you take the square root of 49, that's 7. You take the negative of it, well, the square root of 7 is negative 7. And that's the negative square root. And then when you see that plus minus, okay, that's your signal for both. All right? So what I want you to try right now is 4, 5, and 6 in the triad. Let me see how you do. 4, 5, 6.
2, isn't it 2?
All right? So they ask you for the square root of 4. What's their answer here? Caesar. Huh? 16? Not 16. Not 16. Yeah? 2. Positive square root, right? 2. What about the negative square root of 81?
Negative 9.
Yeah, this is negative 9. That's for the negative root. Negative 9 times negative 9 gives you 81. And what about plus or minus square root of 64?
Plus negative 8.
Yep, plus or minus 8. Because 8 times 8 is 64. And negative 8 times negative 8 is 64.
Do we say plus and negative 8, or do we say plus or negative 8?
Plus or minus, but to be both. Both roots. Yep.
Hey, Isabel, I used the wrong glove. No. How's door knocking going for you? Good. Okay, good.
Yeah, we should
I'll
be.
take care of her later, don't worry. Just wanted to make sure. She heard.
Okay. Now, fraction. Okay. When you have a fraction, especially in the beginning, okay, most of the numerator denominators they give you are going to be perfect roots. So if you're given the square root of 9/16, what you want to do is break the square root up into numerator denominator. The square root of 9 divided by the square root of 16. That's the same thing. All right? But what's the square root of 9?
3.
3. What's the square root of 16?
4.
4. And that's how we can figure out that the square root of 9/16 is 3/4. Just break the square roots up, numerator, denominator. Take the square root of the numerator, take the square root of the denominator. Okay? If some of these problems get a little tougher, there's basically a rule that you can't have a square root in the denominator. That's something for a whole other time. Okay? Right now, most of the time, they're going to give you these that are going to work out nice. All right? And then in B, they have the plus or minus out in front, right? That should mean that we have two answers now, right? The positive and the negative of that square root, right? So what's the square root of 2.25? 1.5, right? And that's going to be positive 1.5 and negative 1.5. Or you can write it as this. Same thing. All right? So now, I want you to find me these root or roots of these guys, these fractions. Okay? Use those examples above. All right? Pause and see how you do. All right, so when the minus sign is out in front, it's asking for the negative root. All right? So, again, think of the fraction, break it up into the two roots. What's the square root of 1? 1. What's the square root of 100?
10.
And then we got the minus on the front. How many people got negative 110? Good. Now, what happens when the plus or minus is out front? What's it asking for then?
Negative and positive.
The both roots, right? The positive root and the negative, right? So again, take the square root of 4, which is 2. What's the square root of 25? 5. And then you have your plus and minus. Plus 2.5 and minus 2/5. And then this one has nothing out in front, so it's just asking for the positive root. What's 12.25 square root? 3.5. All right, as we get to the next part, I want to show you this little thing. So it says squaring a number and finding the square root undo each other. So they are inverse operations of each other. So remember back when we did solving equations, right? We always added the opposites, right? Because if I had negative 6, we added 6, right? That always equaled 0, right? Or if I had a fraction 1/4, right? We multiplied by 4 over 1, which is 1. That's our multiplicative inverse. Or if we had 4x, right? 4, we divided by 4 to give us 1, right? So those were all inverses of each other. Well, so is when you take the square root of something, like the square root of 4, and then you square it. Okay? It undoes the square root. So the square root of 4 squared becomes 4. Why? Let me show you. This really says this. This is the long way. We're going to show you why it is that. So when I multiply two square roots, we multiply the numbers underneath. What's 4 times 4? 16. So this would be the square root of 16. And what's the square root of 16?
4.
So you see how we get from here to here? So this is basically an inverse of each other. So when you square a square root, it lifts the square root sign. It just becomes the number, the radicand, the number under the root. Okay? So keeping that in mind, now we start to evaluate some expressions. So think about back when we did like terms, right? And I gave you something like this. Can we add that together? Can I add 5x and 7? Why? Because they're not like terms. This has a variable and this one doesn't. Well, with this example, it's the same thing. This has a radical in it, square root. So this is saying 5 times the square root of 36 plus 7. Well, so I have to look at that radical and ask myself, can I simplify this square root? Can we simplify the square root of 36? What is it? 6, right? 6 times 6? And now instead of 5 times 36, the square root of 36 is 5 times 6, which is 30. And I add 7 to 30. So I can take that expression and take it all the way down to 37. It's an expression. Why? There's no equal sign here, right? Equal sign makes it an equation. Without an equal sign, it makes it an expression. Okay? If you look at B, now when they start throwing fractions at you, you can always look at if you want to can simplify under the radical first. We really couldn't simplify 36. It's 36. So we just took the square root. Now the fraction inside. Well, now I look at 18 over 2. I know 18 and I know 2 are not perfect squares, right? So I think I've got to say to myself, well, what can 18 over 2 simplify to? 18 divided by 2. 9, right? Yeah, it took a long time to get to there, but yeah, 9. Well, now look how that changes. I couldn't find the square root of 18 over 2 because those aren't perfect squares, right? But now I divide, look what I got. Is the square root of 9 a perfect square? What's the square root of 9? 3. So now I got 1/4 plus 3, which I can just add together to say 3 1/4, right? So always look to see if I can simplify a fraction under the radical before I do anything. Unless like those other examples where they were 4, 9, where you could just square root those, real easy, right? Then look at C. Remember, the square of a square root, right, those are inverses of each other. It lifts the radical to 81. It just becomes 81 minus 5. Okay, nice simple subtraction problem. All right? I want you to try 10, 11, and 12 now. Okay, give you a few minutes to do that one, and then we're going to do the last. We got one more example to do, and we'll do that one together because we only got about 14 minutes of class left. So I want you to try those 3 right now. Let's see how you did. So at number 10, I got to look at the radical. So what's the square root of 25? 5, right? So I'm going to break down my 25, square root of 25 first to 5. Okay? Well, now this is the order of operations. Do I subtract first or multiply? Multiply, right? 15. We're going to subtract 15 from 12, which is? Negative 3. How many people got negative 3 for number 10? That was the answer. Very good. If you didn't get it, just fix it. It's okay. Now, the next one. What's the first thing we have to do, Eden? Because you got this. What's the first thing we have to do here?
48 minus 7.
Yeah, you got the radical here, right? And you got 28 over 7. Well, 28 and 7 are not perfect squares, but you can divide this. What's 28 divided by 7? 4. So this goes down to the square root of 4. Well, what's the square root of 4? 2. And when I add 2 to 2.4, you get 4.4. How many people got 4.4? Okay, good. Simplify the fraction if you can. All right? Now the last one, you have the radical 4, square root of 4, squared. What's the rule when you square the square root? It just 4, right? The radical lifts. And you just get 15 minus 4, which is 11. How many people got 11? Okay, lost a little bit here with that one. Just you got to remember that little rule. When you square the square root lifts. It's just the number underneath the radical. Okay? All right. Last but not least, the last thing we're going to do today. Okay, now using radicals in an equation. Well, solving equations, no matter if you got x's, x squared, whatever, it's always the same. Isolate the variable, right? When we learned solving equations way back in September, right? Every time we had to get x or a or b or whatever the letter was on one side, right? So here, and it kind of starts you off with a nice easy one. So x squared equals 81. Okay. So when we did the perfect squares, right? You don't have to write this. When we did the perfect squares, we knew that the square root of 4, right, is basically saying 2 times 2, which is 2, right? Well, if I square root both sides, what's the square root of x squared? What times what gives me x squared? X. It's x times x. Right? So it's x. So when I square root both sides, the square root of x squared is just x. Because x times x gives me x squared. Okay? And the square root of 81 is 9. Okay? So that equation would be that. Now, sometimes they throw numbers into the fact. Well, again, it doesn't change anything about solving the equation. If I got 3a squared equals 48, well, now we got a number out in front of the letter as opposed to the first one, right? So remember when I gave you something like, 2x equals 8. How did I get x all by itself? We solved the equation. Divide what? Divided both sides by 2, right, to get the x by itself? Right? Because 2 divided by 2 is 1, and 8 divided by 2 was 4, right? That's how we did that, right? Well, same thing applies here. If I want to get 8...
Interruption number of dismissal for Natalie Hanna.
Okay. 3a squared, I want to divide both sides by 3. Okay. 3 divided by 3 is 1, leaving me my a squared. And what's 48 divided by 3? Everybody with a calculator. 16. Now I'm kind of back to where I was up above, right? How do I get a by itself? Square root both sides. And the square root of a squared is a. What's the square root of 16? 4. Good. Okay. So, down here, we got some equations, right? And remember, plus or minus can work for this, right? Because I can plug in a negative 4 and square it. So if I have the square root of k squared equals 169, we would square root both sides first. All kinds of sounds going on right now. Square root of k squared is k, right? What's the square root of 169? That was one of those perfect roots I told you to work on memorizing. Anyone know? Geo knows. 13. And that'd be plus or minus 13, right? If I could plug in negative 13 here, what's negative 13 squared? Positive 169. Okay. Now, when I got a number out in front, all we got to do now is divide. Yeah, add one more step than what we did to the problem 13. Divide by 7 first. So 7 divided by 7 is just n squared. And then how many times can 7 go into 175? 25. Well, look at it. We always keep ending up with these perfect squares, right? So square root both sides to get n all by itself, because the square root of n squared is n. What's the square root of 25? 5, right? Or it can be negative 5. Okay? Not too bad so far, right? Now, the last one, they added this little minus 6. Okay, that's just another step, right? And when we solved equations before, how did I get rid of minus 6 so it's out of the way of 4b squared? Do what? Add it, right? Do the opposite. Add 6 to both sides. So I get 196 equals 4b squared. Okay, now how do I get b squared by itself? What do I gotta do? Divide by 4. How many times can 4 go into 196? 196 divided by 4. 49. It's just crazy how these always end up with perfect squares, right? If I square root both sides, square root of b squared is b, and then I get plus or minus 7. And that is solving equations with square roots. So we kind of took it from the very beginning of finding squares and square roots to actually solving basically a radical equation. Okay. Now, here's how tomorrow's going to work. When we come in tomorrow, there's no homework. However, hold on, listen. You guys are always putting stuff away. No one's listening to what I'm saying. Tomorrow when you come in, you're going to take this little self-assessment. Okay? It's kind of like think of it like a warm-up. It's not a quiz. Okay, so you can exhale there. So it's going to kind of help you kind of see what you remember. And I'm going to give you a little form that you're going to kind of self-grade your quiz. Just kind of see where you're strong and where you're weak at as we go forward, getting ready for the quiz. So we kind of do this every time we do a day. We do a little self-assessment at the end of that. Okay, so think of it as like a warm-up. All right, so there is no homework tonight. So you can take a little bit of time. You want to just kind of review the notes. We're going to take this tomorrow first thing, and you have some time to work on homework in class, which you'll more than likely finish. All right? Good work, everybody.